Okay. Okay. So with your basic object-oriented programming, the kind of go-to example is the example of you've got some object or some class called so you've got some animal class, and that might have a function walk, right? And then you might have a class that inherits from that. So you might have cat, excuse my terrible handwriting, dog. And then your cat might have something like meow, and your dog might have something like bark. So it's kind of obvious that your cat and dog would inherit from animal, and then your cat would have the walk function, and your dog would also have the walk function, but they'd have their separate meow and bark functions. So this type of thing is great for kind of conventional programming, but for games we like something a bit more flexible, and we tend to gravitate toward a system called the entity component system. So the entity component system, instead of having a specific animal class, we've got a generic entity. So we've got a box, basically, this empty box called an entity. And then for all the functionality that we want to write, we've got components. So we might have a component called walk. We might have a component called bark. We might have a component called meow. So this comes in handy when you want something more flexible, right? So if we want to make our cat like we had before, we'd give it the walk component and we'd give it the meow component. We've got our cat. It's the exact same thing, except now it's much more flexible because we can swap out any of these components while the game is running. If we want to make our dog, all we do is give the entity our bark component and our walk component, and we've got the dog that we had before. If we want to make some weird dog-cat hybrid, we can do that too. We can just give our entity the meow component, and that's not a problem. So that's kind of how Unity works, and how it's kind of different from other programming paradigms. And most game engines work the same way. So in other words, each component is a little piece of code, and you can just plug those pieces of codes in, and they'll do the same thing for each different component. You'll see when we get into the editor. I'm going to make a new project. So this workshop is going to be, we're going to be learning Unity through making a clone of Breakout. So are you guys familiar with Breakout or Brick Breaker? It's the one where you've got the paddle at the bottom of the screen and you've got the bricks at the top. Yeah, okay, so we're going to make that one. So this one's going to be 2D, so I'm going to select 2D. And I'm going to name this AGL Workshop number 1. And then create project. All right. Okay, so this is the Unity editor. Just so that we are all seeing the same thing. There are a lot of different ways that you can arrange this, but just so we're seeing the same thing, I'm going to go up to layout up here, and then I like to use the tall setting, but you can really arrange it however you like. And then I like to go up here to the corner where it says game and drag it to the side so that we can see the scene view and the game view at once. So for those of you who are following along. All right. So in order to make Breakout, we're going to need a kind of tall screen. And the way we can do that is by changing some settings here in the game panel. So the game panel is where you can view what your game's actually going to look like when you start to play it. So right here, I go up to the top here, and I'm going to change the aspect ratio. So this is just the ratio of how wide your screen is to how tall it is. So for this game, I'm going to add a new one. Oh, by the way, if you have questions, don't be afraid to just stop me in the middle of this workshop and ask. So yeah, so we're going to change the aspect ratio, and what's going to probably look good is about 9 by 16. 16:9 is usually the kind of regular wide kind of screen that you'll see, but we're going to flip that sideways so that we've got a nice tall screen. So that's the game view. Now if we look in this tab called hierarchy, this is where all our entities are. So recalling what we just talked about with the entity component system, all of these objects that you'll see in the hierarchy are entities. And if you look over in the inspector window, all of these things that are displayed here, these are components. So entities are just containers that we put components in. All right, so this one that we have by default is our main camera. It's got a transform, which just tells us the position data. We've got a camera component, which actually draws our game. And I'm actually going to change the background color to black. Is everyone good? Cool. Yes. So yeah, this is kind of weird with Unity. The aspect ratio is tied to the game panel and not the camera. So yeah, any other questions before we move on? Okay. Okay, so the next kind of piece of the editor we'll look at is the project panel. So down here, this is basically where all of your assets will come from. So like if you've got images or 3D models or audio that you want to put in your game, you'll be able to access it through the assets folder in the project panel here. So I'm going to right-click and create a new folder. And this is where we're going to put our sprites. So sprites are basically images that you can draw on the screen. So I'm going to make a new sprite. Again, I'm going to right-click, create sprites, and then we're going to make the paddle. So I'm going to make a square sprite, and I'll call it paddle. Now okay, so just to kind of recap, we've got the game view, which shows you a preview what your game's going to look like. We've got the hierarchy, which shows you all of the entities that are going to be in your game. We've got the inspector, which shows you all the components that are on a specific entity. And now we can look at something called the scene view. So the scene view is where you kind of manipulate all of your entities. So I'm going to actually create a new entity, which is going to be our paddle, by taking the paddle sprite and dragging it into the scene view. So now we've got our paddle sprite here, and we can see it in our game view. This is what the game's actually going to look like. And we're able to click and drag it around in the scene view here. If you don't have a specific tab, you can go over to any of the windows and click this little icon in the corner and add tab. And you can add a project tab. Sure. So now we've got our paddle. So this is kind of chunky and doesn't look like a paddle. So we can go up to our paddle's entity here and click on it. And then we can check out its transform component. And we want to scale it. So changing the scale of an object is kind of exactly what it sounds like. It'll scale it on different axes. So if you scale it on the X, it's going to get wider. If you scale on the Y, it's going to get kind of taller. So that we can all see the same thing, if you go up to the corner here where it would say layout, you click on here and then click on tall. And then you should get a layout that looks like this. And then I like to just take the game tab and drag it over to the side here. Is that good? All right. And then you might have to fix your aspect ratio. Okay, so now we want this to kind of look more like a paddle. So I'm going to scale this down maybe to 0.5 or maybe 0.4, and then scale it on the X to like 0.15. So that's kind of looking like a paddle now. Okay, so now we've made our paddle, and I'm going to right-click here, and to keep everything organized, I'm going to make another folder, and this one's going to be scripts. And then inside that folder, I'm going to make right-click, create, and I'm going to make a C# script. And this is the script that's going to be controlling our paddle, so that when we move our mouse back and forth, the paddle will kind of stick to it, so we can make sure the ball doesn't fly off the bottom of the screen. So
What was the name of the script?
we're about to name it. It's going to be paddle controller, and then when you click enter, it'll create the script. So scripts in Unity are basically your way of creating components. So each of these scripts, you'll be able to plug into an entity, and it'll show up in your inspector. So let's take your script, and you can drag it straight onto the paddle. And that'll add it as a component. Or you can just take it and drag it into the inspector. That'll do as well. So, just double click on the script, and it should open up in Visual Studio or Mono Develop, depending on if you have Visual Studio installed. Okay, so do we all have the script open? We all got the script open? Yes? Okay. All right, so Unity kind of comes with some features that make it a little bit easier to use than if you were kind of making the system from scratch. So it's got this system for you. It's got some pre-built functions. The first one is start. You should see this when you open up an empty script. You've got a start function. So this function calls every time your game starts up for the first time. So this is where your initialization code will go. So if you're familiar with constructors, it's kind of like that. So you can kind of think of it like that. Update is a little bit different. Update is called every frame. How many of you are familiar with the concept of like the game loop? The game loop. Game loop. Okay, so basically, okay, let me back up. Games work, games are a simulation basically, and in order to play a game through, it's got to be running in a loop. So somewhere in Unity's engine, there's a while loop or a for loop that basically runs forever while your game is running. And each time that loop iterates, it calls your update function. So this function is being called some probably hundreds of times per second. So anything you want to happen constantly, you're going to put inside update. So for instance, input, like if you want to see where someone's mouse is at a specific moment, that's going to go in update. Or if you want to get a key press, that's going to go in update. If you want to move something around or do physics, that's going to go in an update function. So those are our two kind of main functions here. So let's think about what we're trying to do. We're trying to get this paddle to move with our mouse. Also a side note, if you happen to name your script something other than what the actual file is named, you're going to have to make sure the file name and the script name are consistent. Otherwise, Unity will yell at you. So if you're getting that error where you can't drag your script onto your paddle, that's what's going on. So we want the paddle to move back and forth with the mouse, but we only want it to move on the x-axis. Let's actually back up. Let's just see these functions working. So if you're familiar with JavaScript, you know the printing is console.out.print. In Unity, the same thing is debug.log. So let's just log. We'll pass in a string here, but you can also pass in any primitive type here. So a float or an int or anything you can pass in here. And let's just say hello world. We save that out and go back to Unity. You'll see in the corner down here, you've got a circling, progress bar. That's the script compiling. And once it's compiled, we can go up and press. Wait, before we play, does anybody have any questions on that? Yes?
Is debug log and print the same thing?
Yes. Yeah, console.out.println that's the Java equivalent to our debug log. Oh, yeah. So console.write, I think console.write is what it is in C#. But Unity has a specific way to do it, which is debug.log, and that'll make it so that it can show up in. You go to Window and Console. That'll show up in our specific Unity console. So for a regular C# application, yeah, you can use console.writeline. But for Unity, you always want to use debug.log. Did you have a question? Or a comment?
That we have index.create exception.
Yeah, that's interesting. That is Unity being weird. Basically, yeah, the editor will throw random errors sometimes. Don't worry about it. Don't worry about it.
Something's wrong.
Yeah, nothing. Well, yeah, something's wrong. Unity is kind of weird, but otherwise, everything's fine. Was there another question? Okay, so let's press play, and we should see down here our hello world. Oops. Yes, and if you click it, it'll open the console. So we know our script is running. Our script is attached to our paddle, and because it's attached to our paddle entity is running the script. And the start function, when we press start, is printing out hello world. Okay, so now if we do the same thing, did everybody get hello world to print? Yeah. Okay, so if we do the same thing inside of our update function, so if you just move it down to your update function, you should get spam. Yeah. So you see it's just running as fast as possible. I'm getting like 100 calls every second. So
Wait, how'd you get the console?
so you can either go up to Window and come down to console down here and click on that. Or if you've got text down here, it displays down here and you can just click on it once and that will bring it up. So, any questions about the update and start functions? Cool. Let's move on. So, the next thing we have to do is get input. So the type of input we want is the mouse position. So we want to know where on the screen the mouse is so that we can kind of move the paddle to that position. So the first thing, actually before we even do that, let's talk about transforms. So earlier we changed the transform of our paddle to kind of squash it. Now we're going to be changing the position of our transform in code. So in order to, okay, since our script here is on our paddle, we can access the paddle's transform by typing transform. So this transform refers to the transform that's on our paddle. Does that make sense to everybody? So now we can access the different parts of this transform component by saying transform dot, and we want to change the position. So we can say position, we can grab the position, rotation, or scale. Let's grab the position, and we'll set it equal to vector3 dot, or sorry, new vector3. Okay, so vector3 is probably a new type for you guys too. This is a type that comes with Unity. It's basically just if you took two floats and they're kind of packaged together, or three floats and they're kind of packaged together. So all the positions, rotations, and scales are all vector3 types. So x and y is going to be your x and y position on the screen, and your z position we're not going to even worry about right now because we're in 2D. So if we just set the transform position to 0, we should see our paddle kind of snap when we press start. It'll kind of snap to the center of the screen. So transform.position is relative to the object, so it's world space, yeah. So all right, now we need to get input. So we want to get the position of the mouse on the screen. So we can do that by, first we need to make a variable for it. It's going to be a vector2, and we'll call it mouse pose. Let's just call it mouse position. And then, so in order to get input, we use a class called input. Go figure. So input dot and simply mouse position. And that's going to give us a position on the screen where we can find our mouse, and actually returns a vec3. So if we do a debug.log and we debug our mouse position, thank you. We can see that, let's see, collapse. We can see as our mouse moves, we kind of get a live kind of update of where our mouse is on the screen. So if I put it down in this corner, we're getting something really close to 0, 0. and then as I move it to the right, our X value gets bigger. And as I move it up, our Y value gets bigger. So this is giving us position of the mouse kind of in terms of the screen. And this is not, this is good, like we're getting the input, but this is not exactly what we need. We need the mouse, okay, well, better show than tell, right? So logically, you can just plug in the mouse position to the transform, right? And that should, or the transform position, right? And that should make them match. But you'll see that it's not quite right.
So it's transform dot position equals mouse position.
Yeah. So as you see, your paddle probably disappears off the face of the earth. Unless it's very close to the origin. And you can see it kind of, you can see my paddle down here. That's not right. So what's happening is, I guess I can go back here to explain it. There are two different coordinate systems that we're working with right now. First of all, is everybody tracking with this so far? Cool. So there are two different coordinate systems that we're working with right now. When we call mouse input.mouse position, we're getting a value that kind of corresponds to our screen. So this is 0, 0 at the origin of our screen. And then as you go out this way, you get a bigger X and a bigger Y this way, like we saw. When we're talking about our transform of our object, that operates in a completely different coordinate system. So the coordinate system that our transform operates in is a lot like the kind of normal Cartesian coordinate grid that you're used to in class and like from high school, where your origin is your 0, 0 is the center, and then as you go up, you get positive Y, positive X, and this is going to be a negative X and a negative Y. So if we've got our mouse at 0, 0 here, then our transform, our paddle is going to be at 0, 0. But if we move our mouse over here, this is in pixels, so we might be at like pixel 300 and 0 on the Y. And if we move our object here to 300, we're somewhere like way off the screen, when we should only be moving it maybe over here to like 3, 0. Does that make sense?
So it's like the left one is pixels, the other one is just distance.
Yeah, so mouse position is in pixels, and transformed position is in like world units. So we have to do something to fix that. And the way we fix that is we get a reference to the camera that we're using. So in order to do that, this is actually the object that we're getting a reference to, our main camera. So in order to do that, we can say, first of all, yeah, we can give it a, so type camera. We'll call it, yeah, let's call it camera. So in order to get a reference to it, we can call camera.main. And if you hover over it, you can see the type. It returns a camera, and that's what we're getting here. So this will get whatever active camera is, whichever camera is active. So you might have multiple cameras in a scene, but this is going to get the one that's currently like rendering. So yeah. camera.main will usually do the trick. And then once we've got the camera, what the function we're about to call does is it takes this pixel space and changes. So if you've got a point in this pixel space like 300 here, it'll take it and it'll transform it into your world space. So this coordinate system is called world space. So this is world space. And this is called screen space. So we're taking this screen space coordinate and we're kind of transforming it into a world space. If you don't totally understand this right now, it's fine. It's just kind of good to gain an intuition for what we're doing. So camera dot screen to world point. So camera.screen to world point is going to take that screen space position and turn it into a world space position. Yes. Oh, it absolutely doesn't. So, yeah, that's a good point. For the sake of simplicity, I put it in update. But yeah, you're absolutely right. You could have a global camera variable and then assign it in start and then use it inside of update. Yeah, that's absolutely the better way to do it.
You have another question?
Yes.
Does it assign a variable in one of the functions? Does it not work from the function?
Yeah, no. So this is the scope of the update function. So if I tried to use camera out here, I'm not gonna be able to use it.
That's why you would put it in the class.
Yeah. So yeah. Okay. So for the sake of example, yeah, I could have camera out here as a global variable, and then inside of start, I can assign that camera, and then I can use it down here because it's global scope. All right. So is everyone tracking with that? I know it's kind of a lot, so. Okay. So if we hit play now, okay. So the problem now is that mouse position is going to give you the position. Okay, remember earlier when I said we want to ignore the Z position because we're working in 2D? If you have a Z position that's not in front of your camera, your object's not going to show up. So before we use our mouse position, we want to make sure that that Z position is 0. So basically this is making sure that your object's actually in front of your camera, and then we can transform that point. So now if we go back in here, we're still seeing the pedal behind it. Huh? What was that? Oh no, it's not that. It's sorry. So that wasn't the problem. Sorry guys. It's after it's transformed. So let's call this so the problem is that after the camera transforms it, it moves it to where the camera is. Don't worry about that too much. Basically, it's just drawing behind the camera. So we transform the point. We get the new position. We zero out the Z, so it's actually in front of the camera. Now we can use that new position. Goodness gracious. Okay. Yeah, so basically the camera right now the camera's Z transform is -10, right? And it's looking forward. And our paddle Z transform or Z position is 0. So because the camera's in front of our paddle, we can see it. But if the paddle is on the same Z position as the camera can't see it.
I see. Okay.
Yeah.
So it has to be like.
So it's like if my head right now is at -10 and my hand is at the origin, I can see my hand. But if my hand's at the same position as my head, I can't see it.
That makes sense.
That's the same thing that's happening. So we have to move the paddle back to 0 on the Z in order to see it. Does that make sense to everyone? Kind of? We good? Okay. So now if you press play, you should get a paddle that kind of tracks your mouse. Okay. Okay, so now we only want the paddle to track the mouse on the x-axis. So we basically want it to move back and forth like this. I want it to be at the bottom of the screen, probably. So we can just get the x component from this new position. So we want to create a new vector 3. So we want to keep the transform position the same, except on the x-axis. So we want the y and the z to stay the same, but we want this new x position. Does that make sense? Oh. Does that make sense to everyone? So we're computing our new position. We're moving toward, this is where the mouse is in world space. And then we want the paddle to stay where it is on the Y. We don't want it to move up and down. We don't want it to move toward or away from the camera because it's 2D. We want it to move left and right. So we're changing the X to the new position. So does everyone understand that? So if we play it now, we should only get X movement. So when we move it back and forth, it's kind of just tracking the mouse back and forth.
How'd you get it on the bottom?
So you can just, inside of the scene view, yeah, you can click and drag it. In order to...
Just the Y. Like, just don't change the Y.
Yeah, inside the script, we're changing the X and not the Y and Z. Yeah, so that's basically all I kind of wanted to go over today. Is everybody up to this point? Does everyone have their paddle moving back and forth? And like, some of this I just did for the sake of readability, but you can always take the mouse position and just directly transform it. So this will do the same thing. Unless anybody has any questions on that, that's all I had for the first part of the workshop. Next time we're going to talk about collision and kind of getting a ball to bounce around. But are there any questions on just the entire kind of segment?